Let us look into the last exercise of chapter area related to circles. That is the 14th question from that exercise. Here, this is the figure given, and we can see two sectors, and OD and OB are given. The length of OD and OB are given. Since OD is the radius of the smallest sector and OB is the radius of the outer sector, we want to find the area of this shaded region. How we can find? For that, we want to find the area of the largest sector and area of smallest sector. That means we want to subtract the two areas. So, how we can find? So, area of sector OBA minus area of sector OCD. Then, what is radius of the largest sector? That is OB. That is given as 21 centimeter. Area of the largest sector OB is given as 21 centimeter, and area of the smallest sector OC is given as 7 centimeter. Then we want to subtract that two areas. We know that we want to know the central angle, that is given as 30 degree, since angle COD is 30. So we can apply theta by 360 into pi r square. So 30 by 360 into pi into 21 square minus 30 by 360 into pi into 7 square. Here 30 by 360, that is 1 by 12 pi. Then we can apply that identity a square minus b square. Since pi by 12 is common in both, so pi by 12 into 21 square minus 7 square. Then it is 28 into 14. 1 by 12 into 22 by 7 into 22 into 14. After cancellation, we will get 22 into 14 by 3. That is 308 by 3 centimeter square. So that is the area of the shaded region. Let us move into the next question, that is 15th. The next question, this is the figure given. We want to find the area of the shaded region. Here we can see a right triangle ABC and the quadrant. This is the quadrant, and from that we can see a semicircle. How we can find the area of the shaded region? First, we want to find the area of the segment. This segment we want to find area of the segment. Then area of semicircle minus area of the segment will be the area of this shaded region. Here, radius of this quadrant is given. This is not semicircle, it is a quadrant. So, area of this quadrant is given as 14 centimeter. And using Pythagoras theorem, how we can find the length of BC? 14 square plus 14 square, which is equal to BC square. So, 196 into 2. So, BC is equal to 14 root 2. So let us move into the proof. Here, area of the segment is area of the quadrant minus area of triangle. Area of quadrant minus area of the triangle. So what is the area of the quadrant? 1 by 4 pi r square. 1 by 4 pi r square. R is 14. So 1 by 4 into pi into 14 square. Here we can substitute pi as 22 by 7 into 14 into 14. Then we can cancel, and after that we will get 22 into 7. So that is 154. And area of the triangle, that is half BH. Base and height having same length, that is 14. So half into 14 into 14. So 154 minus 98. So that is 56. So the area of this segment is 50. That is, this segment is 56 centimeter square. Then we want to find the area of the semicircle. We know area of a semicircle is half pi r square. So here, for that we want to find the radius of the semicircle. That is why we already find BC equal to 14 root 2. Then area of the shaded region is area of semicircle minus area of segment. Segment we already find, it is 56. So area of semicircle is half pi r square. Since length of that BC is 14 root 2, therefore r is equal to 14 root 2 by root 2 equal to 7 root 2. Therefore half of pi is 22 by 7 into 7 root 2 into 7 root 2. We can cancel these 2 and root 2 and also 1 7. Then we will get 22 into 7 minus 56. So it is 154 minus 56, therefore 98 centimeter square. That is the area of this shaded region. This is the last question. Here this middle part is shaded. Here one square is there 8 centimeter and we want to find the area of this region. How we can find? So let us take this quadrant. That is ABD is a quadrant, and also we can see CBD is another quadrant. ABD and CBD are two quadrants. How we can find the area of the shaded region? For that we want to find the sum of quadrant and area of square. Sum of the areas of two quadrants and area of the square. Here we can find the area of the shaded region. Let us do that. How we can find sum of quadrants? Sum of areas of quadrants. So we know that 1 by 4 of pi r square is the area of one quadrant. Since there are two quadrants, sum of areas of two quadrants are there. So half into pi r square. Since 2 1/4 are there, so it becomes half. Half into 22 by 7 into 8 square, since radius is 8. Then we can cancel 2 and 8. Then 22 into 4 2s are 32 by 7. So it is 704 by 7 centimeter square. Then we can find the area of the square. Area of the square is 8 square. It is 64 square. Then find the area of the shaded region is area of two quadrant minus area of the square. Area of two quadrant is 704 by 7 centimeter square. So shaded area, that is 704 by 7 minus 64. After cancelling and cross multiplication, we will get 256 by 7 centimeter square. So that is the area of this shaded region. So we completed the exercise in the chapter area related to circle. So next we want to study about trigonometry.